Good morning, all. The last slide we have seen the zero knapsack problem solved by the greedy method approach. But right now we have to solve the knapsack problem by dynamic programming. There is a difference. The last greedy method approach we are used solve for knapsack problem is the fractional knapsack problem. But right now we are solving the zero one knapsack problem. Firstly, you have to explain what is the knapsack 01 problem. The goal is to maximize the value of knapsack that can hold at most W units. It may be in a kg worth of goods from the list of items we have given over there. I0, I1 up to IN minus 1. And each item has two attributes. The value, let this be the VI for the II items, and weight, let this be the WI for the I1 item. Value means to say the profit of the that weight we have to consider. That is called the value, and the weight, how much weight we have to consider. This case. The difference between the problem we have solved in the case of the fractional knapsack. One is that you cannot take a fraction of an atom. In that case of the zero one, but in the case of fractional, you can make the by part of that weight of that. Now you can either take it or not. In this case, either you have to select it or not. Hence, the name knapsack zero one problem arises. That's why the name we have considered over there, that is called zero one knapsack problem, either selected or not selected over there. Okay, but in the case of fractional, we will select one or there 1 by 2, 1 by 3, the fractions part of it can be considered. But in these cases, you are the only you have to consider the value that is called 0 or 1, either not selected or selected. That's a name defined clearly. In this case of knapsack problem, the brute force approaches we have taken, the naive ways to solve these problems to cycle through 2 to the power n subset of the n items and pick the subset with the legal weights that maximize the value of knapsack. Whether we normally brute force, we have to apply all the possible conditions. The possible condition that if you have the number of n number of elements, the total n number 2 to the power n subsets of items can be considered. Okay, and we have selected normally the value that have the maximum profit we have to collect at that rate. You can come up with the dynamic programming algorithm that is usually do better than the brute force algorithm, because in the case of dynamic programming we have not say, considered all of the value because the brute force we have applied all the examples, all the possible conditions can be collected. But in the case of knapsack zero column, we will collect the optimal solution of the brute force as we did before we are going to solve the problem. Whenever we have to solve the problem, we just make the sub problem of that. Okay, our first attempt to might we categorize the sub problem as follows. Let Sk is the optimal set of the element. The elements lies that's I0 to Ik, that is the optimal set. And what we find is that the optimal subset from the element I0 up to Ik plus 1 may not be corresponding to the optimal subset of the element of I0 to Ik in any regular pattern will be there. Okay, we have divided the portions of the problem in the two parts. We consider the sum of the optimal subset of the element we have. Basically, the solution to the optimization problem for S k plus 1 might not contains the optimal solution for the problem Sk. Now we consider the examples to solve the knapsack 01 problem. Let's illustrate that point with an example. We have selected the items I0, I1, I2 and I3. According to that, the weight we have 3, 8, 9 and 8, and the value will be the 10, 4, 9, 11. That is the value we need to say the profit of that weight we have to consider, because we normally consider the maximized profit according to the weight we have. The maximum weight of the knapsack, because the knapsack will be considered as the maximum weight can hold, that is for 20 kg, because we have considered all the items, and that items can be as collected in the form of the knapsack, and they can hold the maximum weight as a 20. The base set of items we have selected from I0 to I2 the I0, I1, I2, because 3, 8, 8 plus 3, that is 11, 11 plus 9, 20, and the maximum weight of the knapsack can hold is 20. That's why the base set of the item we have selected, this case 3, 8 and 9, all can be considered. According to that, the 20 cases will be considered. Okay. But the base set of the item we have to consider, if we have selected the I0, I1 and I2 and I3, the value will be again the 3, 8 and 9 will be considered, because the fourth element can't be considered, because the knapsack maximum weight will be the 21. Okay. In this example, note that the optimal solution I0 does not build upon the previous optimal solution. Okay. In this case, the subset we have decided. Instead of build up the solution I0 and I2, which is the really optimal subset of I0 and I2 with the weight 12 or less. So now we must rework the way we build upon the previous problem, and let BKW represent the maximum total value of subset SK with the weight of the W. Total value represent with the case of the subset SK. Our goal is to find the value B n comma W, where n is the total number of items and W is the maximal weight the knapsack can carry. Okay, the whatever the weight we have selected in the knapsack, uh, the goal we have, the value we have collected, the maximized one. Okay, that's we have. This is a recursive formula for the subproblem bkw bk minus 1 w, where wk is greater than w. And if we consider the value, otherwise case, the maximum of bk minus 1 comma w and bk minus 1 w, w minus k plus vk is the value of that success. We will explain these terms k and w by the set of the examples, how we can generalize this recursive formula from the example we have solved. Better to understand what is the k and what is the w, the set we have collected, and according to that example we make this formula used to do the recursive one. Okay. After finishing the example, we will explain what is the k and w. They will be easy to understand to calculate the each cell of the value in the example of the knapsack problem. Okay. In English, this means the subset of Sk has the total weight W is the best subset of Sk minus y minus 1 that has total weight of W, and the best Sk minus has the total weight of W minus K plus 1. That easy task to understand this part by the form of the examples. Okay. Let's knapsack problem. These are the recursive formula. We will solve according to that. Either we can solve the normal cases of the problem we have. Okay. First WKW, and the second case is the WK less than equal to W. Two cases we have to consider, but we normally comes under the part of the second cases, and we solve the examples of the knapsack problem. These are the algorithm we normally apply for the knapsack zero problem. These can be considered, and each step will be clearly explained in the case of the examples. These are the basics form of the problem we have to solve. Okay, let's, let's start the problem and understand what is the knapsack zero problem and how we can solve this by the using of the dynamic programming algorithm. Okay. From the algorithm, we collect some of the data that's called n equal to 4. We are considering the 4 elements. Okay. Now we have considered the elements first, element second, and third and fourth element. And according to that 4 element, the weight of the knapsack is 5. The maximum weight is equal to 5. And the element represent the first element represent the weight of that element, and according to that the value will be there. Suppose the element number 1, the weight of that element is 2, and what is the profit of that, that is the value of that weight is 3. That is the 2, according to 2 the value is 3. Second number of weight, that is called 3, the weight is 3 and the value is 4. Fourth number, third number, weight is 4 and the value is 5. And last one, that is called 5, the value of 6 means we are considering only the four elements, and each elements having the weights, and according to weights the profit have we have. This is the case. Now we make the cases, make the matrix in the form I the value 0, which element we have considered. This is the value 0 1 2 3 because we are considering the four element, first second and third four, and we initialize the sum of the value with 0 0 because if we have not considered the any weight, that mean to say that the value is 0, or if we are not considering the any number of profit we have considered, that the 0 will be there. Okay, so now initialize the case, we make the cell according to the weight, maximum weight we have. As I know, the knapsack knapsack maximum weight is 5. That's why we make the cell first, second, third, fourth, fifth, and sixth. 0 is the blank cell. That's why we have divided the cell in the case of the 5 number of weights. First number of weight, second number of weight, third weight, fourth kg of weight, and 5 kg of weight according to the number of items we have. Okay. So mean to say we make the cell representation according to the maximum number of weight. Suppose the maximum number of next is 8, so you have to make the column of 8. If you have to, the maximum number of weight is 10, then you have to make the maximum number of 10 column of the matrix we have. Okay, and the rows will be the according to the how many number of items we have selected. Suppose here we have selected the four items, that's why 1 2 3 and 4 items will be there. Okay, now it's clear. Now this is the I is called as the number of items, and W is called as the column section is considered as the maximum weight with the individual number of items we have considered. 1, 2, 3, 4, 5. The maximum weight is 5. That's why we have divided into the form of the 5. Okay, let's start. This is the case. Started. By default, the value of 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, y will be the 0. Why? Because if if you haven't selected the value of any number of weight you haven't selected, it means to say the profit of according that would be 0. Okay, the none of the weight we have selected, it means to say the profit is 0. The value is 0. That's why it is written over the 0. And the first case, none of the weight have selected, that's why the weight of that column will be the 0. Okay, no weight, no value, and no weight, no profit. That's why the first row and the first column of the this matrix will be the 0 1. Okay, this is the 0 and this is 0 because neither of the weight we have selected, neither of the value I have selected. That's why we have considered the value that is called 0 0. Okay, now start with the first one. Okay, these are the items we have selected. Why we have considered this item? Because total 1 2 4 item, 1 2 3 and 4 items we have, and according to items, these are the weight, and according to that weight the profit will be there, that the value will be there. The second number of weight is 3 kg and the value is 4. So third number of item is 4 and the profit is 5, and the fourth number of item is the weight is 5 and the value is 6. Okay, we have divided the value according to the weights we have. Okay, value mean to say profit, because we have to maximize the profit whenever we have selected the weight we have. Okay, let's start the first item. The item number one, that is item number of weight, one have a weight that is called 2 and the value is 3. Okay, let's whenever you have to consider these item, we have to initially we have selected the first item. Mean to say we have to selected the first item I1 equal to 1. Okay, in that cases the what is the profit? The profit is the weight of the first item is 2. This is the first weight of the first item is 2. That's why we make the profit accordingly. This is the profit vi equal to 3 because the weight number 2 is the 2 and the value is the 3. So that's why the column number of 2 will assign the value of profit, that's called 3. That's why here the value will be 1 WWA minus 1 according to the formula we have, and that it can be the solution, I can be the solution, and if Vi equal to Bi minus 1, Wi will Bi minus 1 equal to W. Okay, so these are the formula we have already defined. That's why we have written over there all the cases. The first cases, the value will be the, we have selected the first one. That's why the what is the profit of that one? The profit of that one, because we haven't selected the first number, because the weight of the first item will be the 2. That's why the uh, profit will same the previous cell. These are the first row. The first row value will be the same. That's why the 0 will be the same. Okay. Now come to the second one. Now we have selected the item, first item, and the weight of that item will be the 2. This is the weight of the item of the 2. That's why the profit of that weight will be 3. That the value will be the 3. Okay, we have selected the items. That is the second item we have first item we have selected, and that item's weight is 2, and according to that items the profit is 3. That's why we have written over the first row and the second column we have written over the profit, that is called 3. Okay, let's start now. We consider the next one, because in these cases we have considered the only the first item, and the first we have, if we consider the first item, it means to say the maximum profit will be the 3, because the item number 1 profit value is 3. That's why all the selections of the third column of 3, 4, and 5 will be the same as the 3, because the profit always will be the 3, because we have selected the only one item, and that item's profit value is 3. Okay. Now consider the second one. Indeed, second one, if you are considering the second item, it means to say you can consider the first item as well as the second item. Okay, that's what the second profit value will be the 3 and 4. The weight of the 3 will be the 4. This is the case, the weight of the 3 will be the 4, and accordingly this way. Okay, now whatever the value will be assigned the previous one. But the previous one value will be the 0 in the case of 1. That's why we have written over the 0. Okay. Now consider with the second one. The previous profit will be the 3, because the first item will already consider. That's why the profit will be the 3. Okay. Now third case, we have to consider the item, the item weight is 3 and the profit will be the 4, because the previous weight we have considered the 2 and the profit accordingly is 3. Now we can consider the second item also, and the profit value of that item will be the 4. That's why we have written over the 4. Okay. I think it will be the easy why we have considered the 4 over there, because we have selected the second item, and in the case of the first item the maximum profit is 3, the profit value is 3, but if we have selected the second item the profit value is 4. That's why we have written over the 4. When we need to say which one is the higher, either the previous row and the previous row and the previous column will be the value. When we need to say 3 and 3, which one is the case, and the current right now the value of the second item will be the 4, that we have selected the 4 one. Okay. In same way we are going to the calculate the each value of the items of second item. Again we have considered the maximum item. The maximum item value will be the 3, and the profit value will be the 4 accordingly. Okay, this is the case. Now here the case will be there. Suppose the profit, we have selected the first item 2 and the second item is 3. The weight of the value is 2 plus 3 equal to 5. Now actually now we are considering the both of the items we have selected. If we have both the item we have selected, the profit value will be the 7. That's why we have written over the value, that is case the value will be the 7. Okay, so that's why the value will be the 7. Okay. Now third row, in third cases we will consider the all of the three item, either 1, 2, 3, yeah, any of 1 and 2, 2 and 3, and 1 and 3, and as well as the first item, second item, and third item simultaneously. Okay, so that's why the weight and the value will be calculated accordingly. Now the profit value, because we haven't selected, if the weight will be the one, the profit will be the same, zero. Okay, the same value with the same cases, because the value we have selected the three, the profit will be the same. Now in the case of 2 plus 3 equal to 5, 3 plus 4 equal to 7. Okay, the value will be the same. In this case 4, what is the profit value? The we have taken the third item we have selected. Now we have selected the third item and the value is 5. That's why update the value with the previous one, because we haven't selected the last one, the value, the weight of the third item. Now we have selected the item, weight of third item, and the the value accordingly is 5. That's why we have updated the value. Okay. Now third item, the 5, 2 plus 3 equal to 2 plus 3 equal to 5, and the value accordingly is 7. If we have selected the 4 plus 3, that will be the 7. And if we have selected plus 4 plus 2, that equals 6. If there is the no possible cases, we have to consider the first item, third item, second item, third item, and first item, second item, and third item. Because the value of we have selected the maximum weight, that is called, we have selected in the case of the 5, the value will be the first item and second item, the profit will be the 7. Okay, so that will be the same. Okay, now in that cases we have considered any of the item, first, second, third, as well as the fourth. We consider the fourth item, the profit will be the fourth. This case the weight will be the selected the 5, the profit is the 6. But we will not update that value, because the previously we have selected the value 2 plus 3 is equal to 5 and the profit value is 7. That's why we will not update this value. Okay, that previous value will be as it is, and the last value the we have selected the 5. In that cases, the if you have selected the fourth item, the profit value is 6, and if you have selected the first and second item, the profit value will be 7. Obviously it's obvious, we have to select the first and second item rather than we can select the item number third. Okay, so that the profit value will be the 7. Okay, and I think it's going to be clear why you have selected the, we haven't selected the fourth item, because the profit value of fourth item is 6, and profit of first and second item is 7. Which one is the higher, we have to select it. This is the formula we have done. The maximum possible value that can be carried in the next set is called the 7. The profit value is 7. Okay, we have highlighted that part in the case of the red marks. The profit we have collected the items, that is called 7. The maximized profit we have collected in the case of the 7. Okay, this algorithm only finds the maximum possible. In these cases, we have considered which items, the fourth item 7. Okay, and which item we have selected. These can be explained by the following algorithm. We can explain the following, how we can select the items. This is the case. Okay, the items, the maximum property is 7. That's why we have to check which items give the value of 7. In the fourth row, this is the fourth row, the value is the 7. Now we have to check whether it comes from the previous item or it comes from the fourth item. No, this it comes from the previous value. If you have selected the third value, the profit value will be the 7. Okay, now it means to say we haven't selected the fourth item. Now come to the previous row. Again, now we check to the previous one whether the 7 value comes from the previous row. Yes, it comes from the previous row. The items, weight items we have selected, that's the second number of items we have selected, and the profit value will be the 7. Okay, this means now again we have to compare whether 7 value will come from the previous row. No, that previous row is 3, and this second row is called the 7. It means to say we got the profit of 7 from the item we have selected, that is called second. So that's why the profit will be the 7 from the second item we have selected. That's why the I the item we have selected, the second one, that is I0, I1, I2, I2 will be the 1. Okay, item 2 will be the, in the case of the knapsack, item 2 we have selected. Clear? Now we have to consider the next profit value. What is the profit value? We have already used the value of 7, and the maximum value will be the 7. Now calculate the possible value. We have minus the 7 with the item. Uh, we have selected the items with the profit value 7, and the item we have selected, that's called second. The item we have selected is second, and the second item's profit value is 4. So it means to say the profit comes from the second item is 4, and the remaining profit will be the from the different item we have selected. That's why we will minus the item, that is called 7. 7 minus 4, the value will be the 3. So next profit value comes from the different item we have selected, because the item 2 have selected, and the item 2 selected item value will is 4. Okay, that's why now we going to the compare the next profit value is 3. Ki whether 3 comes from the this row. Yes, the first item we have selected, the value will be the 3. Okay, so that means to say we have selected the first item, the profit will be the same. Now will we compare ki whether by default comes from the previous row value. No, in the previous row the value of that item is 0. That means to say the item number 1 is selected, that's why the profit value is 3 comes. Okay, so 3 is the value, and now we will minus the value, because the item number 1 we have selected, and the item number 1 profit value is 3. That's why 3 minus 3 equal to 0. It means to say we have completed the total number of knapsack value, that is called 7. Profit value is 7. We have accomplished the value, that is called 7. Maximum value we have 7, and the item we have selected, that is item number 1 as well as the item number of 2. Okay, so that's item 1 number 1 and item number 2 have selected, and finally the value is the 0. There is no row we have selected, so we are done over the optimal knapsack should contains the item number 1 as well as the item number 2, and the maximum profit value we will consider in that cases, that is called 7. Okay, these are the solution according to me. And now we are going to the calculate the running time of the problem. These are the various code, various case, wait for n4 and the repeat n times. That's why n of w is the running time of the algorithm. In the brute force algorithm, we will going to the apply the 2 to the power n, but in the case of this algorithm, we are going to the apply how many weights we have, the case number of weights. According to number of weights, we are going to the value we have inside. Okay, these are the knapsack problem you can solve. Fill out the dynamic program, type it to the knapsack, fill out to the right, and track back through the table to the find the items in the knapsack. Please. Okay, this comes to the end of the knapsack problem. If any problem, you can message me on the link we have provided. Okay, thank you.